Jai Hind. In this lecture, I am going to discuss very important topic, that is B tree. Now, first of all, we will discuss what is B tree and what is the basic difference between another kind of tree like binary tree, AVL tree, binary search tree. We will discuss here. So, B tree basically is a special type of self-balancing search tree. Main application is for searching, and it has the capability that it can balance itself. And how it is done, we will discuss with the help of example in the further slides, and in which each node can contain more than one key. The basic difference between the previous categories of trees and in this tree is that in the previous cases only one key can be at a particular node, and it can contain only at most two children. That can be 0, that can be 1, and that can be 2. But in this category, it can contain more than one key at a particular node, and it can contain more than 2 children. And basically, it is a generalized form of binary search tree. Already we are familiar with the binary search tree, and in binary search tree, at each node, its value must be greater than from its left side children and must be less than from right side children. And the another name for this tree is hide balance M-way search tree. Here M is the order of the given tree that will be given in the question, and as we discuss, at each node it can contain more than one key. That here we have 2 keys, here we have 2 keys, here we have 2 keys, and all the values should be in the sorted form. That means if we are putting any value, so the value lesser than 20 will be the left side of this, and value greater than 40 will be right side of this. And for this, because it is the special generalized form of binary search tree, so all the property that we have already discussed in BST will be included in this B tree also. And we will discuss further with the help of example. Now, in a B tree, the M is the order of the given search tree, and it should satisfy the following properties. The first property is the root has at least 2 child. That can be more than 2, but in a B tree, the root node must contain at least 2 children. The second property, every node has at most m children. The maximum number of children for a particular node, that can be m, and m is the order of the given tree. The third property, every non-leaf node means that is not a terminal node except root, has at least m by 2 children. This is like this, m by 2, we will whatever order is given will be given, we will divide by 2, and we will take the maximum of that is the maximum values at a particular node can be. A non-leaf node with k children can contain k minus 1 keys. That is, if it has k children, then maximum keys will be always k minus 1. All leaf nodes that are also called terminal nodes must appear in the same level and carry information. That means all the terminal node, all the leaf nodes must be at the same level, or you can say at the bottom level. Now, in this lecture, I am going to discuss about the insertion in a B tree. Now, B tree, in case of insertion, we will do the 2 operations. One is searching for the appropriate node where we can insert a new node, and if condition is violating, then splitting the node if required. What is the meaning of that? For example, if m is 5, then in that case at a particular node maximum values can be m minus 1. If more than that, then we will split that particular node. Insertion operation always take place in the bottom up approach. That means if we are splitting the node, then it will increase in the upward direction and all the leaf node will be at the same level. Let us understand with the help of an example. Now, for example, these are the elements that we have to insert into an empty search tree, or you can say into an empty M-way search tree, where M is the M equal to 3. Now, the maximum values that can be, that is M minus 1 by 2, that is 3, and that is the upper value, that means maximum value that can be 2. Now, how insertion will take place? First of all, we have to insert 8. So, that is we have inserted 8 here. Then we have to insert 9. The maximum values that are allowed on a particular node, that are 2. That means if we are inserting another value, that will be 8 and 9, because 2 values are allowed at a particular node. Then we have to insert 10. If we are inserting 10, then in a sorted form, always we have to insert the value in sorted form in the ascending order 8, 9, 10. But maximum values that are allowed on a particular node according to the given order, that are 2. That means here condition is violating. We have to split that node, and in that case the middle value will be moved to the root, and left values will be the left child and right value will be the right child. That means it will be like this. And as we discussed, all the leaf node will be at the same level. Now the next value. Now after that we have to insert 11. Now first of all we will compare 11 with 9. 11 is greater than 9. Then we will come to the right side, and because at a node 2 values are allowed, then we can put here like this: 9, that is 8, that will be 10 and 11, because we have to put all the values in a sorted order. Next, now after that we have to insert 15. Now first of all we will compare 15 with 9, and according to the sorted it will be after 11, that is 9, 10, 10, 11 and 15. But again here condition is violating, because according to the given order maximum values can be 2. Now again we will split this node, and mid value will be moved to the root like this, that is 9 and 11. Because it contains 2 keys, then it will contain 3 child, always m plus 1, that is 8, that is 10, and that will be 15. Now next value we have to insert, that is 20. Now according to this, now we will compare 20 with the root, because 20 is greater than 11, then it will come to the right side and it will be like this: 9, 11, that is 8, that is 10, that is 15 and 20, because at a particular node 2 values are allowed. Now next value that we have to insert, that is 17. Now we will compare 17 with the root values. 17 is greater than 11, then it will be after 15 and before 20, just like this. So that is 9, 11, this is 8, 10, 15, 17, 20. But again at this node condition is violating, because maximum 2 values are allowed according to the given order. Now again we will split this node, and mid value will move to the root. But again here will be the 3 values, condition will be violated here also. And again we will split this node, that is 9 will be the root, then and here we have 8. Already we have 10. Here we have 15, and here we will have 20. So in that way, B tree will be constructed. And let us take another example. Okay. Now, for example, these are the keys that we have to insert in an empty binary tree. Sorry, into an empty B tree. And this time, the order given is 5. So first of all, we will find out the maximum values, that is m minus 1. So in that case, it will be maximum 4 values. Maximum 4 values that we can insert on a particular node. So first of all, for example, we were inserting 1, then 1 is inserted. Then after that, we have to insert 12, then it will be 1, 12, 1 and 12. Okay. Then because according to the given order, maximum 4 values are allowed. Then after that, we will insert 8. That will be, because we have to put in sorted form, 1, 8 and 12. Then after that, we have to insert 2. Then it will be 1, 2, 8 and 12. After that, we have to insert 25. Already we have inserted these values. I am putting the tick so that we can find out up to what we have inserted. It will be like this: 1, 2, 8, 12, and that is 25. But here again the condition is violating, because only maximum 4 values are allowed. Then according to the rule, we will split this node and the mid value will move to the root, that is 8. Then here left values will be the left side children, 1 and 2. Here will be 12 and 25. Okay. Then after that, we have to insert 6. Now according to rule, 4 values can be, then we will compare 6 with 8. That will go to the left side and it will be like this: 8, 1, 2 and 6, because we have to put in the sorted form. That is 12 and 25. After that, we have to insert 14. Now we will compare 14 with 8, then we'll go to the right side and it will be like this: 1, 2 and 6. Okay, and here it will be 12, 14 and 25. After that, we have to insert 28. We will compare 28 with the root value, then we will go to the right side, and because here we have only 3 values, we can insert 1 more values. It will be like this: 12, 14, 25 and 28. Still 4 values, that means no violation. After that, we have to insert 17. We will compare 17 with 8, then we will go the right side. Now it will be like this: 1, 2 and 6. That is 12, 14, 17, 25 and 28. But again on this node, condition is violating because more than 4 keys. Then we will split this node and mid value is 17, that will move to the root. Now it will be like this: 8, 17, here will be 1 to 6, here will be 12, 14, and here will be 25 and 28. After that, we have to insert 7. Now we will compare 7 with this root values, because it is less than 8, then it will with the left side, and it will be 8, 17, it will be 1, 2, 6 and 7. Again it is 12 and 14, and these are 25 and 28. Now after that, we have to insert 52. Again we will compare this value with the root value, and we will decide it will be after 17. That means in this node. That is 8, 17, 1, 2, 6 or 7. This is 12, 14, 25, 28 and 52. Okay. After that, we have to insert 16. Now we will compare this value with the root values, then we will insert here. It will be like this: 8, 17, 1, 2, 6, 7, and here will be 12, 14 or 16, and here values are 25, 28 and 50. We will go to this node. Now initially it contains only 3 values. 1 values can be put it here, and it will be like this: 8, 17, 1, 2, 6, 7. Here 12, 14, 16. Always we have to put the value in a sorted order. Then after that 48, that means 25, 28, 48 and 52. Now after that we have to insert 68. If we are inserting 68, then definitely it will be in this node like this: 8, 17, 1, 2, 6, 7, 12, 14, 16, and here it will be 25, 28, 48, 52 and 68. But again here condition is violating, then we will split this. Okay. Now we are going to split this node. Now it will be like this: mid value will be 48. It will goes to the root node, that will be 8, 17 and 48. Now here 3 keys, children will be like this, not this one. Okay. Again, I'm doing this. Again, I'm splitting due to some erasing problem. That is 8, 17 and 48. Now here we have 3 keys, that means 4 children. That is 1, 2, 6, 7, 12, 14 and 16. Because here we are splitting, 25 and 28 will be the left side and 52 and 68 will be the right side. Now in that we can insert more values like this. For example, we are inserting 3, then we will compare 3 with this root and it will be here, just like this. 8, 17, 48. It will be like this, 1, 2, 3, 6 or 7. Here 12, 14 and 16. Here 25 and 28. And here 52 and 68. Again here 5 values, maximum values allowed are 4. We will split this node and this time 3 will be goes up. So that is 3, 8, 17, 48. Now 4 keys, that means 5 childs. Left side will be 1, 2, 6, 7, 12, 14, 16, 25, 28, 52 and 68. Now again, for example, we are inserting 26, then 26 will be here. Then for example, we are inserting 29, that will be after this 28, because 4 values are allowed. Then we are inserting, for example, 53, that will be after 52. That is 52, 53 and 68. For example, we are inserting 55. Here 3 values, that will be after 53, that is 55. And for example, we are inserting 45, and again 45 will be 29. We will compare this, that is 45. Again condition is violating and mid values are 28. Then we will move this value here. When 28 will come, again condition will violate and mid value will be up. So I am also doing this step. If 28 is coming here, then 17 will go up. Here will come 3 and 8. Here will come 28 and 48. Here left side will be 1 and 2. Here will be 6 and 7. Here are 12, 14 and 16. Here left side 25 and 26. Here will be 29 and 45. And here will be 52, 53, 55 and 68. Now finally we have to insert 67. So 67 will be before 68 here. Again the condition will violate, then we will split this node and 67 will goes up, just like this. Then in that case 52, that is we are inserting 67 here, it will be 55 will goes here, and in that way we can perform the action.